Hello, my fair-weathered YouTube friends. It's been about a month since I've been on the boob tube, and I thought I'd get back on what would bring me on YouTube after a month of taking a vacation and other such things. Well, it had to be big news, and it is nothing other than Polars, that goat of data frame data engineering libraries based on Rust. Yes, Polars got me back on the old tubes. What is it about Polars, you may ask? Yeah, well, GPU execution. I discovered while slowly rolling through the internet looking for something interesting to write and talk about. I ran across a Polars blog, and in there I saw a little tidbit, something about a little bit GPU execution. I was like, what the heck? I've not heard about this. What's going on? You are not going to believe it. It blew my pants off. Literally 70% speed increase on 40 gigabytes of CSV files with aggregation. 70% speed up GPU execution. Who's not talking about this? Why is nobody talking about this? I have no idea. Well, I'm talking about it now. Basically, Polars had a little tidbit on their blog saying one of the core philosophies of Polars is to utilize all available cores on your machine. One type of computational core that makes up a lot of compute power is a graphics processing unit, or GPU, and they done did it. When I first read this, I was like, this either means everything or nothing. You know, you see some of this stuff, and, you know, I've tested a lot of new things out. Some stuff doesn't work out. People say, whatever, and then it turns out to nothing. So up front, I was like, oh, I don't know. Is this something written for some massive Facebook company running a whole data center and they're using Polars or something like that for some crazy machine learning stuff? And, you know, that's where it's going to benefit someone, or is it for the everyday user like you and me? Well, apparently it's both, and it's very, very good for the everyday user, as I found out, although there are some caveats, and I'll get into that in a minute. Basically, I'm an idiot, and I don't know what I'm talking about, but, you know, Polars GPU engine, they say now supports larger than memory GPU VRAM seamlessly using a unified virtual memory. I don't really know what I mean. I think it means that it just takes your computer's memory as well as your GPU, and it's going to use them both. Hopefully more of the GPU because it's faster and spill back to your normal RAM, whatever. Anyways, it magically pulls that GPU into the RAM available for Polars to do all sorts of crap, and it makes it blazingly fast. Now I want to walk you through a couple screenshots of what I did, how I got it actually working. I did have a little bit of troubles here and there. I think it's important just to talk about that so we're all on the same page and you can see it wasn't just a simple walk in the park, and there's some caveats, but whatever. I got GPU processing to work with Polars, and I got a 70% speed up. It's crazy. Okay, so I have a brand new M4 MacBook that my boss so kindly provided for me, and it's pretty much a couple weeks old, so I thought, you know, what better? Let's go ahead and try to use this on my Mac. We'll just do some local tests and see what happens. So after poking around, I did find a little bit of examples. There is some benchmarking code that Polars wrote on their GitHub page, GitHub repo, whatever, and it kind of gives us at least an idea because I couldn't really find any other documentation surrounding this. I kind of like just snuckily sent it out on the blog, didn't really talk about it. And then it's just some benchmarking crap in their GitHub page. Maybe they'll come out with some documentation. Maybe I just couldn't find it. There's basically nothing on the internet about it. Went ahead and read through the benchmarking code on GitHub just to kind of give me an idea of how are they using this, etc., etc. They have a bunch of configurations, blah, 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 blah. But it turns out you can just run this one-liner thing where in Polars you have either eager execution or lazy execution. Lazy meaning it's going to kind of stream the data, not pull everything into memory at once. Whereas eager would be like, pull it all in, baby, right now I want it. Anyways, if you run it in lazy mode, you typically at the end have to run a .collect with your final result saying, go ahead and do the thing now because you're in lazy mode. And in that collect statement, you can say engine equal GPU, apparently. And that's magic. That's it. Boom. Walla bing, walla bang, walla boom. You've got GPU flying on your machine. Although, if you have a Mac like me, slow down. Anyways, we needed a baseline, so I went ahead and pulled in the Backblaze hard drive dataset. It's free and open source dataset about hard drives that fail in a data center. I got all of 2024, and it turned out to be 40 gigabytes on disk to play with of CSV files, about almost 400 CSV files, a total of 40 gigabytes uncompressed. And basically, you can see here's a bunch of the files. This is what they look like, blah, blah, blah. Just a bunch of boring data in there, like a date and a serial number of a server and if it failed or not, that hard drive on the server, blah, 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 da, 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 da. Anywho, I just needed a baseline. You can see the baseline code here, meaning I'm just going to run vanilla polars without GPU execution. And FYI, I ran it a bunch of times on the machine. So that way, if my basically laptop decides to cache data, etc., then we would all be good. So I, ran it a couple times and took the last 3 runs as the average. This is the code, so you can just see a lazy data frame. We're just scanning the CSV buckets, about 350, 390, something like that, about 400 files, 40 gigabytes. Just doing one of the simple group by, right? I'm just going to group by the date, and then I'm just going to count the number of failures that happened, sum them up, just very simple. Failure column has a 1, a Boolean if it's failed, so I'm just going to go ahead and count those per date. Just collect that, print the results. I just want to see how long this takes. 40 gigabytes on vanilla polars. You can see the results here, of course, of the last 3 runs. 45 seconds, 44 seconds, 44 seconds. Pretty consistent. Good to see. Not bad. Polars doing an aggregation, 40 gigabytes of CSV, 45 seconds. Not bad, not bad. Next, I was like, okay, let's go ahead, and I was using UV to do this. So UV add polars GPU, that's what you have to do to get stuff installed. They started puking on me, blah, blah, blah. Basically, you need to make sure you have the latest version of Python. And what you'll realize later is that you ain't gonna be able to do this on your Mac. I'm sorry, you can't do it. It starts crying about CUDA, blah, 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 all this kind of stuff. You can read to get all this. Hey, you need to install Polars GPU with this extra index URL, blah, blah. Keep going, da, 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 da. No go, baby. And of course, remember I said result collect engine GPU. That's all you need to add, supposedly, to make the GPU computation run. No, man, it's still crying, screaming. You'll get Python to install stuff. Flipping Python, man. But in the end, what it comes out like, CUDA Polar, it just don't work on your flipping Mac, man. I don't know what I'm doing. I tried every single thing under the sun. Finally, I pretty much realized after I kind of did a little bit of Googling around, I went some weird places on the internet, like usual, and wider problem. I found somebody saying, hey, CUDA, doesn't matter what you do, but if you got ARM-based Mac, NVIDIA does not provide CUDA for those systems, so you're up the creek, man. Oh, well, they would have saved me a lot of time if I would have figured that out beforehand. So what did I do? I went on Linode, so I have a personal Linode account. I went and found about the cheapest GPU I could find at 50 cents an hour. I got to get this thing done or go broke. Don't leave it on overnight. Went ahead and set up this GPU, this Polars GPU machine. That is GPU. Of course it is. What am I saying? 50 cents an hour, whatever. I don't know much about GPUs. I don't get into that stuff. Anyways, it uses an RTX 4000 ADA, whatever, GPU accelerated machine. I don't know. Anyways, I just picked that thing, 16 gigabytes of RAM plus a GPU. Then, of course, I went through and reinstalled Polars GPU with the NVIDIA extra URI, and it actually installed and worked correctly, which, okay, apparently you need to have a NVIDIA capable machine GPU, so you're not gonna be able to do it on your Mac. I don't know about Windows because that stuff sucks. Anyways, and I just went ahead and copied all that data up to that machine, all that 40 gigabytes of stuff. Woo. NVIDIA RTX 4000, what you gonna do for us, baby? And remember, all I did is just the same exact script I showed you before, just .collect. I just put engine GPU. That's it. Okay. And oh, by the way, I reran those same non-GPU runs and took the last 3, and it wasn't that much different from my Mac. It was 44 seconds, 45 seconds on vanilla Polars up on that machine and on my Mac. Anyways, that's what I did. Of course, I tried running this again on an NVIDIA machine. It blew up right away. Whatever, CUDA thing. I did this extra pip install of CUDA-QU12. What the Python? What is this thing? I could be installing malware. I don't know what this is. Anyways, went ahead and installed that just based on some stuff I read. Apparently, even if you have a GPU enabled machine that you get from some cloud company like Linode or whoever, they don't actually put the flipping software on there to support, that GPU. Why don't they do that? I don't know. You would think. Anyways, you have to install this yourself. Extra index URL, NVIDIA, the CUDA thing. So you basically have to get all that stuff on there. It failed again. It's blah, blah, blah. I got a sudo app install, a bunch of NVIDIA driver crap, get that stuff on there. Okay. I just ran this command, and finally it's okay, this machine believes that there's a GPU, something to do with CUDA and NVIDIA that exists in general. Hopefully I can run this code now. And I did. I just took that same script with that engine equals GPU and I ran it, and you won't flippin' believe it, man. Holy crap, 13 flippin' seconds. Holy cow. You can see it here. I mean, holy buckets, man. It's like 70% speed up, and all I did was, granted, play around a lot, find a machine that has a NVIDIA GPU enabled thingy, whatever. I mean, in production, you could do that easily enough. Look at the speed up increase just using that GPU as the engine. Holy crap. What is this black magic? I don't even know this is real. It's witchcraft, man. That's insane. 70% engine speed up with the pipeline. All I did was say collect engine GPU with polars. Bang. That's crazy. I didn't make that stuff up. I can't believe they're not talking about this more. This is a classic problem of smart engineers make smart things. They're really bad at marketing and business, apparently. Why wouldn't they be trumpeting this from the highest hills? I have no idea. I don't know. That's crazy. Insane speed ups. You know, people are arguing about what's faster, DuckDB or Polars. Well, Polars is now, suckers. Sorry. I guess the real question is, in a production-like environment, if we had to buy some short-lived GPU compute machines and run our pipelines, we got a 70% speed ups. Clearly, those GPU machines and compute cost more than non-GPU compute. But the non-GPU compute is running 70% longer at a cheaper price. I don't know. Does it work out to be the same? Someone would have to do that, but dude, that's fast as crap, man. And that's what got me back on YouTube. Congratulations, Polars, you rock.